All right, yo, what's good? So, this particular lesson, finding roots of polynomials using the rational root theorem, it's going to feel kind of out of order because we've already kind of moved past this thought process of using synthetic division because that comes back right now. Um, Typically, you talk about this after you talk about synthetic division, but for whatever reason, we're talking about it now. So what happens is, if you remember, synthetic division, it's a way of finding a particular way of factoring polynomials that are of higher degree, and typically a root is given to you. And then you can, for instance, like here, if I want to factor this using synthetic division, I have to know a root. This example, it kind of like walks you through and it tells you, okay, well, first use 1, and then, whatever happens, use -1, and then just see what happens, right? Okay, so they're given to you. But the point of this particular lesson is, if you think about the pool of numbers that you have to choose from, like what numbers can I choose from? Well, to be quite honest, you could choose from any number from -infinity to infinity, right? There's an infinite amount of numbers you could choose from. So this particular lesson is a way of narrowing down the list to just a handful of numbers. Otherwise, you just start at 1, then -1, then 2, then -2, until you find one that works. But sometimes those numbers aren't even in the list. So what this is saying is that if you take the way you make the list, this says to take P, which is the last number, the constant, and put it over Q, the coefficient of the leading term. So, and it's the factors, right? The factors of P, the factors of the constant over the factors of the first coefficient, the leading coefficient, right? Factors are numbers that multiply to make that number. So for instance, list all the possible rational zeros. So this is going to be factors that make -8. Technically 8, right? But it's -8. So this is going to be, and it's always plus or minus, right? It's always plus or minus. So it's going to be 1 times 8. That's the first factors of 8, 1 times 8. And then 2 times 4, right? 1, 2, 4, and 8. These are all the ways that I can multiply to make 8. 1 times 8, 2 times 4. And you take the positive and negative of each one of those. And you put this over the factors that make 1, right? Because that 1 is the leading coefficient. It's the number in front. So how can I make 1? Plus or minus 1, right? That's the only way. Okay, so now what has to happen is, now that I have my fraction set up, we actually need a list. And the way you make the list, you take everything that's on top and you put it over everything in the bottom. So for instance, we have 1 over 1, which is basically plus or minus 1. Then we have 2 over 1, and that's basically 2. 4 over 1, plus or minus 4, and then 8 over 1, plus or minus 8. Now, if the front number was something other than 1, you'd have to, this list would get longer, right? You'd take everything and put it over everything in the bottom. But here's my list, right, of numbers that I'm going to use, or that are possible zeros, right? X-intercepts or solutions, right? They all mean the same thing. Zeros, X-intercepts, solutions. So -1, positive -1, positive -2, positive -4, and positive or -8. So it's really 8 numbers. So I went from -infinity to infinity, right? Infinite amount of numbers that I could try. But I know that using this particular method or technique, the possible zeros are dwindled down to just 8 numbers, right? The positive and negatives 1, 2, 4, and 8. So one of these is guaranteed to be a 0. It's guaranteed. So let's just get down to the business here. So this is going to be, they say to first try 1. I'm going to try 1 because 1 is the first number in the list. Now, to be quite honest, you could probably not make the list and just start with a 1 and negative 1, and like you would eventually get there. But like if you did that, you could be testing numbers that aren't even on the list. For instance, like 3 and 5 wouldn't be on the list. 6 and 7 wouldn't be on the list. But typically you would have hit a 0 by then. All right, so let's get it. So if you remember, you take all the coefficients. You take all the coefficients, and we start the synthetic process. Always bring the first number down. And then you multiply 1 times 1. Write that here. And then you add 3 plus 1. Multiply times 1 plus negative 6 times 1. And then plus negative 8. This comes out to negative 7. All right, so right now, what this means is that positive 1, right? X equals 1 did not work. It's not a 0. It's not a 0. So let's try negative 1. So negative 1. Again, 1, 3, negative 6, negative 8. All right, bring down the 1 times negative 1 plus 3 times negative 1, 2 plus negative 6. So this is going to be negative 8 times negative 1 is positive 8, and this makes a 0. So this means that x equals 1 is a 0, right? X equals 1 is a 0. So now let's find the rest of the zeros. So what happens is this was x to the 3, right? X to the 3. That was the original degree. Well, when you do synthetic division, if you recall, the answer that you get, it's always 1 degree less. So what this is saying is that this is a quadratic, right? And if you try to factor this quadratic, right, x squared plus 2x minus 8, using traditional methods, right, 2 numbers that multiply to make negative 8 that add up to 2. All right, this may or may not work, right? If this doesn't work for whatever reason, we could do synthetic division again using numbers from our list. So 2 and 4, let's call it, so negative 2, right? 2 times negative 4 is negative 8. But 2 plus negative 4 is not positive 2, right? This actually, it looks like it's gonna work, but it doesn't, right? This doesn't work. And then the only other option is 1 and 8, but again, that doesn't work either, right? So traditional methods won't work. Now if I want, I could try to use another one of these numbers, but I'm gonna use the quadratic formula because that's typically what you do when it doesn't factor, right? Because if it doesn't factor using the traditional methods, and it's a quadratic, I don't think any of these other numbers are going to work on this list, to be quite honest. So this would be A, let's call it A, B, and C. And remember the quadratic formula, negative B plus or minus square root b squared minus 4ac all over 2a. Okay, so let's start just plugging in what we know. So b, so negative 2 plus or minus square root 2 squared minus 4 times a times c, negative 8, all over 2a, 2 times 1. Okay, this is going to be negative 2 plus or minus 2 squared is 4. Negative 4 times negative 8 is positive 32, which is actually really nice. And this is going to be over 2. Okay. 4 plus 32 is 36. That's awesome because square root of 36 is 6. So this is going to be negative 2 plus or minus 6 over 2. So we have two answers. We have negative 2 plus 6 over 2 and negative 2 minus 6 over 2. So negative 2, sorry, you can't see it. So negative 2 plus 6 is 4. 4 over 2 is just 2. Negative 2 minus 6 is negative 8. Negative 8 over 2 is just negative 4. All right, so our roots, and if you notice, right, if we would have kept going on the list, if I would have done 2, right, 2 is the next number on the list, that actually would have worked, you know. But I mean, that's trial and error, right? It could have worked, is all I'm saying. Should I show you? And let's show you. So look, check it out. Okay, so what this is saying is we tried 1, we tried negative 1, it didn't work. So I'm going to try 2. So going through the process with 2, this is going to be 1 times 2. When you add, you get 4 times 2, you get 8. And then when you add, you get 0. Okay, so what this is saying is I know that x equals negative 1 is a 0. I know that x equals 2 is a 0. And so think about this. X3 was the original. X2 was the answer to the first time we did synthetic division. And this is going to be x plus 4. Right, because the degree, it always goes down by 1. So really, x plus 4 is equal to 0. And you basically subtract 4 from both sides. So you see that x is equal to 4. So these are our 3 zeros. So you could have kept doing synthetic division, actually. But it may not always work, right? Like, it may not always work. In this case, it did. So then if we try to graph this, so remember, these are the solutions or x-intercepts. So it's going to be negative 1, positive 2, positive 4. All right, something else that we can identify is the x-intercept. Or I'm sorry, the y-intercept. Intercept. So the y-intercept, that's the constant at the end, right? The constant here was negative 8. So negative 8 is the y-intercept. All right. So far we have the x-intercepts and the y-intercept. The only thing we need now are the end behaviors. So remember, we find the end behavior by looking at the degree of the polynomial. This degree is 3, right? It's a third degree. Ultimately, it's odd. It's an odd number. So that means, right? Remember, odd number falls to the left and rises to the right. That's what the ends do, right? So that means it's going to start somewhere up here and then end somewhere down here. All right, so this is supposed to be -4. My bad, -4. All right, so we have all the pieces together, right? We have the end behavior, all the x-intercepts, and we have the y-intercept. So I know that the graph is going to come down to the left. So it's going to go towards -4. It's going to cross. At some point, it's going to turn around. We don't exactly know the height. We don't necessarily care either. So it's going to come down, cross at -8, turn around towards 2, and then go towards the arrow. Right? I mean, does it have to touch the arrow exactly? No, it doesn't. We're looking for accuracy, not precision, right? I don't exactly know where it's going to touch. I mean, I could plug in one of these values if I wanted to be precise, but I just want to get the big idea of the direction, right? End behavior, zeros, and y-intercept, those are the big ones. Let's try another example. We only got a couple, so we'll list all the possible rational zeros. So again, you take factors of the last number. So plus or minus 1 times 8. And you can do plus or minus 2 times plus or minus 4. Now, you don't have to write them in order. Like, it truly doesn't matter. These are actually the same numbers as before. And then over the leading coefficient, which is 1, right? X to the 4th, that's the largest one. So plus or minus 1. 1 times 1 is 1, right? -1 times -1 is still positive 1. So this list is actually the same as the last list. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Right? Every combination of top over the bottom. Okay. Here they're telling us to do what we just did using 4, then -1, and then 1. All right, so let's just follow their lead. Me, typically, I like to start with 1. That's just out of habit, but they want us to do another one. So let's just see. We're going to start with 4 because that's what they told us. So this is going to be 1, 2, -9, -2, 8. All right, bringing down the 1 below the line. 1 times 4 plus 2 times 4 is 24 plus -9 is going to be 15. Right, 9 take away, or 24 take away 9 times 4, 60 plus -2, 58. All right, 4 times 58. This is going to, well, whatever it is, when you add 8, this is not going to be a 0, right? It's going to be something else. So looks like 232 maybe. Plus 8, 240. All right, so x equals 4 doesn't work. Let's try -1. 1, 2, -9, -2, 8. Okay. bring down the 1 times negative 1. When you add positive 1 times negative 1, when you add, you get negative 10, makes positive 10. This is going to be 8 times negative 8 gives me 0. Okay, so negative 1 works. Negative 1 works. So negative 1 is definitely a 0. So we'll just put that off to the side. Negative 1 works. Okay, so now they say to use x equals 1. So watch. I'm just going to continue the synthetic division process again. Bring down the 1 times 1. When you add, 1 plus 1 is 2 times 1. This is going to make negative 8 times 1. When you add, you get 0. All right, so this means that x equals 1 is a factor. All right, so let's think about this for a second. Originally, we had x, what was it? X to the 4th. That was our original leading term. After you do the synthetic division, once you find the 0, it's 1 less, x cubed. And then it's 1 less again, x squared. So x squared plus 2 minus 8. This is actually, well, why do I know that number? This is just like our other problem. 1 plus 2 minus 8. We know that 2 works. So if we try it with 2, right, 2 is definitely in our list. So if we bring down the 1, 2 times 1 is 2, plus 4, or plus 2 is 4, times 2 is 8, we get 0. And this is going to be, so now this is going to be basically x plus 4. X plus 4 equals 0. Subtracting 4 from both sides, so x equals negative 4. So our roots, x equals 2 and x equals negative 4. So negative 1, 1, 2, and negative 4. And that's just from using synthetic division, using our list. And then we happen to notice that we got the zeros from the last problem. It's kind of fortunate. So negative 1, 1, 2, negative 4. All right. So now when we go to graph this, again, remember the constant represents the y-intercept, which in this case is positive 8. So graphing all the things that we know. Positive 8. What was it? 1, negative 1, 2, negative 4. Negative 4, negative 1, 1, and 2. So we graphed our x-intercepts and our 1 y-intercept, and now we look at the end behavior. This was a 4th degree, which is an even number, right? An even number. So I know that the ends are going to either open up or they're going to open down, right? One of these two. Well, the 1, the term or the coefficient in front of the variable, is a positive number. So these are definitely going to open up. The ends are going to open up. So I know that the ends are going to go this direction and this direction. They're going to open up. So now, let's kind of connect the dots, right? Again, not trying to be precise here, but comes down, it's going to cross at 4. At some point, it's going to turn, come back up. I don't know how far down it goes. I'm just, ballparking it. It's going to go up, cross at 8 for sure. That I know. Come down to 1, turn back around at 2. Actually, it might be kind of symmetrical, to be quite honest. All right. Well, not symmetrical, but, whatever. All right. And then up. It makes more of a curve, not so much of a point. But there it is. This is the general idea. So, recapping, what did we learn? We learned that we can factor any polynomial by using the rational root theorem, which is basically you take the factors of the constant and you put them over the factors of the coefficient of the leading term. And this narrows the list down to what you want to try and use for synthetic division to try to find the possible zeros. Right? There's going to be a lot of trial and error. Like, don't get me wrong. This isn't, right? This was kind of designed a certain way for it to work out. But, you know, it may not always work out. And there's going to be a lot of trial and error in my experience. All right. Hopefully this helps. Catch you guys in the next video.